Hey, welcome back, guys. But before we start on day 3 of chapter 1, I wanted to make sure that I answered any homework questions you had and that we had a chance to look at it and see how you guys did. So, this is from day 2. This is part of our homework on page 3. So, a stop sign. Hopefully, you guys said that is a plane. Number 2, the tip of a pen. We know that tip comes to a point. The strings of a fiddle, well, strings are very long and straight. We know we're looking at a line, or in this case, the lines. A car antenna. I know not a lot of cars have these anymore. If your parents drive an old enough car, maybe, but they look kind of like that on a car, and so we know that is a line. And a library card, something I wish more people did have. We know that is a flat surface. We're talking about a plane. Last part of our homework, guys, had to do with the multiple choice. Had to do with on page 4 of day 2. And these are a little bit tougher. So let's talk a little bit about them. Number 1, look at this figure. Where do planes A, C, E, so A, C, E, looking at that right there, and B, C, D, B, C, D. So let me go with a different color here. So we've got B to C to D. So here's that second plane, and our first plane is going to be that. And so it's asking, hey, where do these planes intersect? Well, some of you guys can see it right here. You can see where the colors overlap. We're looking at CD. Next up, what is the smallest number of distinct points that can define a plane? Well, we know that 1 point is just a point. 2 points can give us a line, but until we add a third point, we do not have a plane. But as soon as we add a third point, if they're all on this same level, we can have ourselves a plane. So 3 points. At how many points can 2 distinct lines intersect? Well, think about this, guys. If we have 2 lines that intersect, how many points are they intersecting at? Just 1. If 2 lines are coplanar, that means we have 2 lines on the same plane. Something like, let's say, here's a plane. We'll call it Q. Let's say we got a line here and a line here. What's something that has to be true? Has to be. No chance it's not. Well, the 2 lines intersect. That may not be true. What if they're parallel? So that's not necessarily always going to happen. The lines never intersect. Well, there's a good chance they're not parallel. So these 2 lines could potentially intersect. So that's not guaranteed. All points on the lines are coplanar. Ah, that's what I'm talking about. All these points on both lines, we know if these lines are coplanar, all their points are going to be coplanar. There's our winner. How about this one? What is the intersection of 2 distinct non-parallel planes? Well, we actually saw this up here. What's the intersection of 2 planes? What did you see here, guys, on number 1? Looks like they intersected not at a point, but at a line. So if 2 planes are intersecting, they're intersecting at like a seam, a line. And then final one, name the line and plane shown in the diagram. Now, at first, you think this one's pretty easy, but be careful. Line SR, okay, I like that. And plane, ooh, UT. What's the problem there, guys? If you're going to name a plane based off points have to have 3 of them. Plane UT is not going to work. That's only 2 points. Same thing's going to happen for D. Even though the line's good, plane UR not going to work. So it's either got to be B or C. And if you notice, they both have the same planes, but the key here is we don't actually have a name for this line. This isn't line L or line Q. It's just a line with 2 points. So we have to label it based off those 2 points. So line RS and plane RSU. So before, guys, we jump into our last lesson of the week, I just wanted to thank you guys for being patient with yourself, with your technology, with me this week. I know in some ways it's been a challenging week, but it's kind of awesome to get back into a routine. And I really do believe that as we get better with technology and as everybody gets more comfortable with things will get a little bit smoother as we go. So don't panic. We got this, guys. We're in this together. And this is just 1 week. We're going to have 35 more great weeks. Time to get back to it, guys. We are moving on to Chapter 1, Day 3. And this is a day where we're really going to start to dig into the details of lines, points, and planes. So we had a chance to introduce them yesterday. Now we're going to kind of get into the weeds a little bit and see some specifics about geometry. And as you can tell, we're not going to be straying too far from yesterday because our standards are the same. For the most part, we've got postulates, theorems on points and lines and angles. And then here's the key too, being able to understand points, lines, and distance. That's going to be one we haven't really talked about yet, along a line in a plane. So distance is going to be really what we focus, especially the back half of today, on. But let's do a little exercise here. I'm curious to see if you guys have carried anything over from these last couple days. Try multiple choice number 1 for me. All right, did you guys say DM? We can see that, or MD, either way. We can see that ED is the whole as far as these 2 points stretching fully apart, but they still make up this line, just like M and D do. They make up this line. Now, moving away from lines, let's talk about something that's a little bit shorter. Line segments. Man, telling you what, these circles, I should have gone to summer school to work on my art skills, but line segments. Now, these are kind of like lines, the words in it itself, but they're only segments. They're just the set of the points between 2 endpoints. So line segments have a beginning and an end. They're not infinite. And you can see 2 examples right here. And instead of doing like we did up here with DM with the arrows, we do things a little bit different with line segments. We have 2 here, AB and PQ. Instead of doing a line with arrows at the end, we can just draw a flat line, no arrows, because obviously arrows mean that something's going on forever, and these 2 segments aren't. Now, if we're getting into real definitions, then a big one is going to be congruence. This is a definition that's going to carry over pretty much the entire course throughout the year. And all congruency means is that 2 things have equal measure. And that word equal probably stands out to you because you're used to seeing an equal sign. And the congruent symbol is very, very similar. It is that with a squiggle. So congruent is an equal sign with a squiggle above it. And one way we show congruency is not only can we see sometimes distances are the same, but to demonstrate that, we will actually draw what I call tick marks, like ticks on a clock. You can draw maybe 2 here and 2 here. And you want to draw the same number on each to show that these two are congruent. So we would say, in this case, AB is congruent to CD. And the reason that is because 10 equals 10. So last definition on the page, and really one of the last things we're gonna look at as far as definitions are concerned, is betweenness. Sometimes we go medieval on this thing and we call it betwixt. I know that looks like a word from the Middle Ages, but all this means is that a point is between two other points. And this happens, number one, if we have 3 points, and number two, if from one point to the middle point, and from that middle point to the other point, adds up to be the whole segment. And in geometry, we refer to this, let me adjust my camera real quick, we refer to this as segment addition postulate. It means if you add up two pieces, it adds up to be a whole. And you're going to hear me a lot of times calling this seg add post. It's kind of the abbreviated form of it. So I'm going to stop blowing hot air right now, and I'm going to let you guys see what you think about this example. Which of these points, X, Y, and Z, is going to be between the other two? Go ahead and pause and tell me what you think. If you said Y was in the middle, that's fantastic. But the question is why? Well, some of you guys may have pieced it together. If we see that from X to Y is a chunk, and then from Y to Z is the other chunk, and that adds up together to be X to Z, we can see that we have part plus part equals whole. We know that Y is betwixt X and Z. Now, why did I put a question mark here? Well, that's because we weren't told enough information to know we don't know where Y exactly falls. The problem is we know Y is between X and Z, but we don't have enough information to know if Y is in the middle, if Y is closer to X, if Y is closer to Z. That's something that we really need more information on, and that in most math problems we will get more information on. All right. So here's a little throwback, flashback problem for you. We're going to turn this into an Ed puzzle. So take some time and see what you guys think on these four. And when we unpause it, you'll have the answers. You can double check yourself here. A little throwback to yesterday. I feel like most of you guys probably absolutely crushed that. So I think today we may see a little bit more challenges, but based off what I saw from yesterday, you guys really showed me what you knew, and that's a good thing. So what we're going to do is I'm going to have you guys take a little break. Stand up, walk around, stretch. That's what I'm about to do. And then we're going to hop back into page 2 when you're ready. All right, welcome back. This next section, we're going to rapid fire this because you are in my accelerated class, and ain't nobody got time for that. We can see we've got 5.5. The key here is centimeters. If there's anything you're going to take away from this section, always label units. I will not be able to stress that enough moving forward. Always label your units. We've got 2.25 inches for this flashlight on beside the ruler. And then for this band of stars, looking like we've got 4.2 centimeters. All right. Next up, let's start dealing with some algebraic values. Oh yeah. We're going to start mixing in some letters with these numbers. So we're going to find the value of the variable. So if we're finding the value, that means we're probably creating an equation. And we're going to do this if we have KL, if K is between J and L. So we're going to find the value of the variable and KL if K is between J and L. So let's talk about some things we know here. We know that we've got J L, and we know K is somewhere in the middle here. Now I'm going to assume K is closer to L, and here's why. We're told that JK is 6R, while KL is only 3R. So it would stand to reason that if JK is, almost potentially twice as big, that stretch is going to be a little bit wider. Now here's the thing, if that's the case, and we know that JL is 27, then we have ourselves an equation. If from J to L is 27 and part plus part equals whole, we know 6R plus 3R is going to be 27. Combining like terms and solving this out, 9R equals 27. We end up with half our answer right here. R equals 3. Now we were asked to find the value of the variable and KL. So if we know what R is, we still have to find what KL is. But that's going to be the easy part. We take 3, plug it into R, and you find out that 3 times 3 going to be 9. So what I'm thinking now is, now that you've gotten an idea of what we can look for with seg add post, part plus part equals whole, I'm going to let you guys try numbers 2 and 3. So you can pause and give these two a shot. So we can see we had a kind of an old school Algebra 1 problem here for number 2. Once we set this plus this equal to the whole, combine like terms, 2s plus 1s is 3s. Subtract 3s over to combine with 5s, we get 2s. Add 10 over, 2 plus 10 is 12, and then you divide 12 by 2. We find out that s equals 6, and when you plug that back in to KL, we find out that KL is going to be 8. All right. Now you're going to notice something interesting here on number 3. We're told that Q is actually the midpoint. Means it falls in the middle of this line segment. Well, guess what that means for each of these pieces? That means we have congruency. So PQ is congruent to QR, and whenever you set those, we see we don't have a total, and the reason we don't have a total is because we can set each of these equal to each other. We know 6x minus 7 is really just going to be equal to 5x plus 1. And when you subtract 5x over, add 7 over, you end up with x equaling 8. And if you plug those in, of course, we find out you plug in 8 for x. We end up getting 41. And of course, 41. And so PR, we double those. PR is going to be 82. So if that's half and that's half, you double them up, the whole is 82. And so before we get to the final page, guys, I just wanted to again give you a chance to practice. The one thing I will say, maybe to help you guys out here, is help you with some fractions, because we're going to see a couple fractions here, and I don't want you guys to freak out. So we're told that C is going to be between A and D. Now we don't know exactly where between, so I'm going to keep it, why'd I do that? I'm going to keep it kind of vague. But we do know that AC is 2 and 3/8, and CD is 1 and 1/4. Now, if we want to find the whole, there's a couple ways we can do this. We can either turn these into improper fractions and add them using a calculator, or we can just straight up try and add them by hand. The problem is going to be that even though the 2 and the 1 aren't the issue, these fractions are. Because if you're going to add fractions, we have to have common denominators. Well, if that's a denominator of 8, we need that to be a denominator of 8. But wait, we can do that. We're just going to have to change the overall fraction. How can you turn 1/4 into a fraction that has 8 as its denominator? Well, you double it. But if we double the denominator, to keep it the same fraction, we have to double the numerator. So another way to write this would be 1 and 2/8. Because well, guess what 2/8 really is? That reduces down to 1/4. And so we're going to add 2 and 3/8 plus 1 and 2/8. 2 plus 1 is 3. 3/8 plus 2/8 gives you 5/8. And so we can say that AD, not Anthony Davis, is 3 and 5/8 inches, because we're actually told this time what we're looking at. And number 2 is a little bit simpler. I'm not going to work this one out, but I will. If you want to pause, I will unpause here in a second and have this answer, but I'm probably not going to work that one through. But if you need any more practice, you are more than welcome to try it. And there is number 2. If you'd like to take a look, double check yourself. This time they gave us the whole in a piece, so we had to subtract that piece from the whole to find the missing part. On to the last page. So this next section is going to be pretty straightforward once you get an idea of what's going on. We're given 4 coordinates, and we're also given their place on this number line. So take a quick second, you can pause the video, to place these points on the line. All right, hopefully you've done what I've done here and placed these points correctly, and you may have gone a step further like I did and gone ahead and labeled how far apart each of these points are. And so from there, again, you can kind of pause and take some time to answer these short 2, 3, and 4 questions. And I'd say there's one of these questions that probably got a few of you guys, maybe more than a few. We see that number 2, QR, that line segment, definitely the shortest, but here's one that probably got some of you guys. Which line segment is the longest? Well, you can go all the way from P to S, and that's from -12 to +7. That is 19 spaces. So pat yourself on the back if you got that one. And then we're busting out the squiggly line. That's what's up. We got PQ and RS that are congruent. Let's finish strong here, guys. Finish strong. Next 2 problems, we're just going to say, hey, are these segments congruent or not? Because sometimes you're not given a line. Sometimes you're actually given shapes, and you have to compare sides, which are really line segments. So TU, is that congruent to SW? 2 is not congruent to 3. That is a no. How about number 2, though? AD congruent to BC. What do you see right here? I see 1 tick mark, and I see another tick mark. 1 and 1, the same number of tick marks. We have a congruency. And finally, we can see the finish line, ladies and gentlemen. We're going to put all the pieces together. So take the next couple minutes, and I want you to use the information given to very carefully, hopefully in pencil, label each of these distances. And then we will be ready to wrap up with some multiple choice homework. Let's see what you guys got. We're told that from Michelle and Nancy's house, it is 2 miles to the dog park. From Uncle Bobby and Aunt Jessie's house, it's 3 miles away. So you see that labeled here. We've got grandmother lives just 1 mile away. To ride the bus in the morning, they have to walk 1/2 mile to the bus stop. And the Lakeview rest area is exactly halfway between Dogs our fun park, and Uncle and Aunt's house. So there's actually a couple things we can add on here. If Michelle and Nancy's house to the dog park is 2 miles, and it's only 1 mile to Grandma's house, we can assume then that from Grandma's house to the dog park is also going to be 1 mile. And likewise, if from their house to the dog park is 2, and their house to their aunt and uncle's house is 3, we can assume that from the dog park to their aunt and uncle's house is 1. And if that's 1, and we know Lakeview Rest Area is halfway between these two, we can assume that's 0.5 and that's 0.5. Great lesson today, guys. No, this one was a little bit longer. Thank you for sticking with me, staying focused. And so our homework, of which we'll hopefully have maybe a fun little alternative assignment, maybe a Delta Math, maybe a Google form, will be over our multiple choice right here. Also, stay tuned for a future Delta Math. I'll be sure to post if that goes up, but that will probably be something that doesn't come up until a little bit later, maybe at the beginning of next week. So thank you guys so much, and I hope you have a great weekend, and I hope I get to talk to you soon.